Welcome to The Explainer. Today, we're going to tackle a question that sounds super simple, but trust me, the answer unpacks this whole hidden world behind the AI you use every single day.
So you type in a prompt, you get a response back. Feels pretty direct, right? Like you're just talking to it. But here's the thing. Your words don't just land in some digital filing cabinet. No, they go on a real journey.
Yeah, your words are traveling through this incredibly complex ecosystem of software and hardware, and it's all governed by these rules you've probably never even read. To really get this, we have to start with the AI's biggest weakness. It's designed to forget everything.
Okay, so here's the core problem. Every single large language model, right out of the box, has this kind of digital amnesia. It's stateless. Without a super sophisticated support system built around it, it literally wouldn't remember what you said at the beginning of your sentence by the time you got to the end. So engineers have to build this entire architecture just to give it a memory.
And the way they solve this is pretty cool. They basically create a kind of artificial brain, and it has 4 distinct layers of memory. Each one has a very specific job. Think about how our own minds work. We have those fleeting thoughts, then we have conceptual knowledge, hard facts, and then places to store really complex stuff like images. AI systems, they work in a surprisingly similar way.
All right, layer 1. This is the here and now. It's called the context window. Think of it as the AI's immediate consciousness. It's holding your current conversation in this temporary space, kind of like the RAM in your computer. But, and this is key, the second you close that chat, poof, that memory is gone. That is, unless it's deliberately saved somewhere else. Okay, so for anything more long-term, we need layer 2, semantic memory. Now, this is where things get really interesting. This is where your words get turned into these mathematical representations called embeddings. It's the magic behind what's called retrieval augmented generation, or RAG. It lets the AI pull in knowledge based on meaning, not just keywords. It's how it can remember the key ideas from that PDF you uploaded last week. Now, this third layer might actually surprise you, because it's just a good old-fashioned database. Seriously. This is where all the really critical, structured stuff lives. Your user ID, your payment info, your settings. This is the part of the system that makes sure the business side of the AI just works. But, not all data fits neatly into those nice, tidy database rows. When an AI generates a picture for you or writes a bunch of code, those big, bulky files need a home. And that's layer 4, artifact storage. Just think of it like a specialized hard drive that keeps the main databases from getting totally bloated and slow. And check this out. Here's how it all comes together. You can see these 4 layers, right? From that temporary context window all the way to your permanent account data. Each one uses different tech for different jobs. This whole idea of separation of concerns is what makes a production-grade AI system actually work without falling over. Okay, so we've got the digital layers down. But where in the real world does this AI brain actually live? That brings us to the physical journey of your data.
And this leads to a massive decision every single company using AI has to make. Do they rent their computing power from a giant provider like Amazon or Google, that's the cloud, or do they build and manage their own servers, which we call on-premise? And this choice, it has huge implications.
And you see this dilemma playing out all over the real world. A retailer might put its shiny new AI in the cloud for speed, right? But then all its sales data is stuck on these ancient local servers, and suddenly you have a massive bottleneck. On the flip side, a hospital has to keep patient data on-premise for privacy, but their own servers might not have the super powerful GPUs they need to run the AI efficiently. It's a real trade-off. And this whole dilemma is why we're seeing this third hybrid model becoming incredibly popular. Apple's a great example. As they explain it, the idea is to do as much processing as possible right there on your phone or your computer, that's on device, for maximum privacy. And only for the really heavy lifting, the more complex stuff, does it send your data to a special secure cloud that's literally designed to protect and then forget your information. So this table kind of breaks it down nicely. You've got the cloud, which is amazing for scale, but you're sharing control. Then there's on-premise, which gives you total control, but man, is it expensive. And finally, on-device, or edge, which is the fastest and most private, but it's limited by whatever hardware you have in your hand. The big takeaway here is that there's no single best answer. It's all about picking the right tool for the right job.
Okay, so we've covered the tech layers and the physical locations. But there's a third, and arguably the most crucial piece of this whole puzzle, the rules. The company policies, the fine print. That's what ultimately decides what happens to your data.
And get this, these policies are not set in stone. They change. Take Anthropic, for example.
They're dramatically cutting the data retention time for developers using their API, slashing it from 30 days all the way down to just 7. I mean, that is a huge shift towards greater privacy.
And for their most sensitive customers, we're talking big companies in finance or healthcare, some AI providers now offer something called Zero Data Retention, or ZDR. In this mode, your prompt is used to generate a response, it gets checked for safety in real time, and then it's gone, vanished, nothing is stored. It's maximum data security.
But look, for you and me, for the regular user, probably the most important policy detail is this. Is my conversation being used to train future AI models? And the approaches here are all over the map. Anthropic now asks consumers to opt in. If you do, they keep your data for 5 years. Google, on the other hand, saves your activity by default for 18 months, and if your chat gets flagged for human review, it can be kept for 3 years. And then you have Apple, with its on-device focus, building a system where they say they will never even see your personal data at all. Totally different philosophies.
Yeah, when you see the policies laid out side by side like this, the different company philosophies just become crystal clear. It's a whole spectrum, right? From Apple's super privacy-first on-device model all the way to the more data-centric approaches that really rely on our interactions to improve their models over time.
Okay, so we've peeled back all these layers, the technology, the infrastructure, the policies. So what does this all mean for you? Why should you actually care where your prompt goes?
Well, it really boils down to 3 fundamental takeaways that can help you navigate this whole new world.
First, your data isn't just sitting in one place. It's on a complex journey through multiple systems. Second, where that data physically lives is a constant balancing act between speed, security, and, of course, cost. And third, and maybe most importantly, the fine print really matters. Those company policies are the ultimate authority, and they give you the power to choose how your data is used, but only if you know where to look.
So you see, understanding this system is about so much more than just technology. It leaves us with a pretty profound question to chew on. As we use AI to draft our emails, to generate our best ideas, and even to store our memories, who really owns these extensions of our own thoughts? Something to think about. Thanks for watching.